Welcome back, everyone. This is Jonathan here for the Make a Pong series. And in the last video, we got our game working to a pretty good point, but there is an issue, as you can see, with the computer paddle. When the ball is moving slowly, not so much when it's moving quickly, but when it's moving slowly, the paddle is very jittery and it kind of looks like it's having a seizure. Even as the ball is on the same level and just going completely horizontally, you can see that the computer paddle is having some issues. And so this kind of has to do with code executing too many times, particularly in the update function. So what we can do to fix this is add an invoke. So just to bring you to my notes for a second, invoke is a method within Unity, within C# that we can use to add a delay to our code. And the format, the way we do this, is by typing invoke, open brackets, open quotation mark, and then we type the name of the method that we want to call as a string. So we have to put that within quotation marks, and then comma, and then we have our delay time. So that's a float variable. So you can either put in a variable and assign it a value somewhere else, or you can just type the number in there directly, but whatever goes there, that will be the delay time. And I've already tested this out to make sure it works, and I just wrote these numbers here for my own reference. So we're going to add a 0.05 second delay, and we're going to use parameters of 0.15 for our if statement. You don't know what that is yet, but I'm going to show you that right now. So let's head back over to Unity and MonoDevelop. So let's go ahead and open this here, and right away what we're going to want to do is make sure we're not always calling the computer paddle, because right now it's in a constant state of flux with our if statements. The computer paddle it's having problems figuring out, is it above the ball or is it below the ball, and it's happening so quickly and it's getting called so many times that it just keeps going back and forth, back and forth. So here's what we're going to do. We're going to make an if statement here, and we're going to say if the paddle position, so paddle position y, is greater than or equal to ball position y, and so I want to make sure this has two conditions here to be met, and it is less than or equal to, first we have to type this over again. So if paddle position y is less than or equal to ball position y plus 0.15 f. Now let me break this down. We're basically saying if the paddle position is at the same, if the computer paddle position is at the same level as the ball, and it's within a range of 0.15 Unity units higher than the ball, then we're going to do something here. But I also want to cover this on the other end. So I want to put an OR statement here. But because of the nature of the way I'm doing this, I'm going to put this in probably a different, let me catch my thoughts here, and we're going to do an else if statement. And our else if statement is basically going to be the opposite, saying if the paddle position is lower than the ball. So we're going to reverse these brackets. We're going to say if the paddle is lower than the ball within a range of 0.15 f. And if you're wondering why I've picked these numbers, well, I did some testing before I made this video, and these just seem to get the job done kind of well. So again, this double AND statement just means both of these conditions have to be met at the same time. So what are we going to do here? Well, first of all, we are going to need to call up another variable, and we're going to call this variable private bool paddle pause. And now we're going to go back down to our computer paddle, and we're going to essentially pause the paddle from moving for a second. So we're going to say paddle pause equals true. And same thing down here. I'm just going to say paddle pause equals true. Now we're going to call a delay, and we're going to say for our delay, invoke paddle delay. That's the name of the method we haven't created yet. And if you recall from my PowerPoint, I already figured out that a time of 0.05f works fairly well for what we need to do here. So again, I'm going to, oops, only paste it in once. And what we need to do now is put a return statement underneath this. So if basically what return does is it just, if this line of code is read, the method will end. It will not go on to read this safe statement and the other stuff underneath. It will just back right out. So I'm going to do that right up here as well. Return. And now we actually need to create a method called paddle delay. So we're going to go down here. We're going to write void paddle delay. And just something to point out, you'll notice this code is not showing up in red, even though we hadn't created this yet. If we had started the game, it would not work. We would have some problems. But because it's a string, it does not show that there's an error. And in void paddle delay, all we're going to do is we're going to turn paddle pause back to false. Now, one more thing we have to do is actually make sure we're not moving the computer paddle when paddle pause is set to true. So if we go up here into the into the update function, right here where we have the move computer paddle, we can write in here if there is no paddle pause, then we can move the computer paddle. And by writing the exclamation mark here next to paddle pause, that basically just says do whatever the opposite of this is. So if we didn't have this, we'd be saying if paddle pause is set to true, move the computer paddle. But we're saying if, by adding the exclamation, we're saying if paddle pause is set to false, move computer paddle. So if we're pausing the paddle, we're not going to move the computer paddle. And make sure that all gets saved. And let's just go test that out and see if that works, or if I made an error with my code somewhere. Okay, so we can already see that the computer paddle, the ball's moving slowly, but it's not just shaking in place. And actually, I'm glad this happened here, because this is another little error that is happening. Sometimes the ball is not bouncing off of the top wall, and for that record, it's not bouncing off the bottom wall, and we can just get caught in this endless loop. So let's take care of this right now and make sure that doesn't happen either. So let's go back into MonoDevelop and go into our ball script. And over here, where we're already dealing with collisions, we're going to add a couple of else-if statements. We're going to say else if collider.gameObject.name equals top wall, and again, whatever you're typing here under .name equals, it must be the same as what you have it named here in the hierarchy. So I have this name top wall and I have this name bottom wall. If I don't have it, if I don't call for them exactly like that, exactly as they're spelled, this won't work. So if we're basically if the ball is bouncing and colliding with this top wall, what we're going to do is just add some additional y position velocity to it. So it's hitting the top wall, we want it to go down. So I'm going to just say, I'm going to give it an extra bounce of minus 0.25f. And then, of course, we're going to do the opposite. We're going to say if it's hitting the bottom wall, we want it to bounce upwards. So now I can do 0.25f, and I haven't really tested out these values, so I'm not sure how well this is going to work. Float has some invalid arguments. Oh, I need to put the letter F after here. If you're using a decimal point, you must always put that F if it's a float. And now let's test this out. Okay, so that kind of does a job. You can actually see it speeding up a little bit there in the up-down. And maybe you're going to say that's a problem. That's up for you to test and figure out what you think. Personally, I actually kind of like it because it does increase the pace of the game a little bit. It makes things go a little bit faster. And here we go. We can see we're getting some extra bounces in, and it's just it moves. It makes it a little bit easier to score. But basically, the computer paddle is looking a heck of a lot better now. Our ball is not getting stuck in an endless boring loop. So again, if you're not happy with these numbers, play around with them, find something you like, but that is the gist of how we can solve these bugs. So I hope you got something out of this video. Thanks very much for watching, and I will see you in the next one.